First is related to the structure of diamond and graphite, and usually frequently found in public exam, and explain in terms of bonding and structure why diamond and graphite have different, mainly on electrical conductivity only. But of course can ask other physical properties like hardness, like solubility, like other. Okay, but for conductivity it's actually quite easy to answer. Why? Because for graphite, only 3 single covalent bonds. That means there will be delocalized electrons. Okay, and you need to use the correct word. I found some papers using mobile ions or mobile electrons, something like that. But and in fact, it's the delocalized electrons. And why diamond cannot? Because diamond form 4 single covalent bond without any delocalized electrons. So not difficult, easy, but you can answer the correct words. Okay, you need because ask you in terms of bonding and structure, you need to mention the bonding 3 single bond and also 4 single bond in diamond. Okay. Shh, quiet please. Now for B is a very complicated wordings, okay, like with a diagram, okay, to have fullerene. Okay, of course related to graphite and diamond because all composed of carbon atoms. Now for part B, why we use helium? Of course it is inert and mainly prevent oxidation of carbon by oxygen because under high temperature, the carbon can be oxidized. So we use helium gas and inert gas, that means that no more oxygen inside, will not form any carbon dioxide. And then why we need to have under low pressure, asking you 2 questions in part B. Why we don't have, why we need to inert gas, because it can be oxidized. Low pressure, because facilitates vaporization of carbon atoms. In fact, it's related to physics. Okay, but you know, I need to make a contrast with other students with higher ability or lower ability, but shh. In fact, the students can answer part 1 only. Okay, low pressure because we want to have vaporization of carbon atoms to form carbon 16. Carbon 60. Now, part C. They have, no matter graphite or fullerene, will have a delocalized electron, but they have different electrical conductivity. Because graphite is free to move between layers, but for carbon 60 is simple molecular structure, hinders movement of electron. That means in the bulky ball, the electrons are not delocalized. Remember, in fact, fullerene, non-conductor. How can it conduct electricity when adding potassium metal? And also, under very low temperature, it can be a superconductor. Okay? So part D, why suitable to use as lubricant? Because weak granular forces can slide each other. And also, the surface area, just like a sphere, which is small. Okay, just like ball bearings, okay? You know what is ball bearings, okay? 一啲所謂嘅 bearing 喺啲汽車零件裏面，可以令到嗰啲 contact surface area 細啲，咁個摩擦力會低啲。And lastly, a physical property, okay, to distinguish 2 samples. One is carbon 60 and the other is graphite powder. So we add addition of benzene. Someone write down organic solvent. In fact, it only dissolves in benzene. Okay, so organic solvent is not good because too general. And graphite shows no observation, but carbon 60 can dissolve. This is only one physical property we learned from fullerene. Okay, and I think most of you answered well in 1A, but B, C, D, E is not good. Or maybe a bit detailed for fullerene. Now, we move on to question number 2. Now for question number 2 is easier. For bromine solution and aqueous solution, suggest a physical method. Many of you write down reaction rather than physical properties because not having the question clearly read. Many of you write down addition of bromine or addition of chlorine, etc. to show displacement. However, displacement is not physical method. We simply use heptane. If bromine solution will show orange red, so it is a physical method to confirm it is bromine. Remember, we need to confirm it is bromine, but not showing it is iodine. Someone mentioned adding starch to both of the solution, and if it turns to dark blue, that means it is iodine, which is not bromine. Please bear in mind, we should use the method that show it is, but not show it using a method to show it is not. Because you need to prove it is iodine, prove it is bromine, but not prove it is not bromine. Now, part B suggests a method, to show bromine or iodine is strong oxidation, and this one related to redox, and displacement reaction. We add bromine to Ki, and of course, spartan solution form because it forms iodine. So part C is related to part B, showing the redox reaction and the whole reaction, not just half equation. This one you need to clarify. And this is for question number 2. Any problem? Now, we move on to question number 3. Because last time I used another angle, the video cannot concentrate in the middle. There will be some problem. So I need to make it straight, or I can magnify one by one. Now for question number 3A is a simple calculation of enthalpy change. And I found that some of you can answer well because you still remember the first part. You need to draw a cycle, the equation, what you need to find out. And given to you is the enthalpy change of formation, so this part will be element, and then you point the arrow up for the product. And many of you without times 6 for formation of carbon dioxide and water, and that's why your calculation is wrong, and eventually you list the method, and then you can arrive the answer. And I find that some of you write down positive sign. In fact, a combustion, remember, all combustion enthalpy must be negative because release energy, exothermic reaction. And part B, you need to find out, outline the procedure, how to find it out. But I find that for experimental part, many of you cannot answer it well. Go home and please have a look for all the reaction procedure, like titration, like prepare standard solution, like dilution, etc. So how to have this experiment? Now we have a known mass of water, of course in volume because the density of water is 1. And then take record for the temperature T1. Burn a known mass of glucose, to heat up the water, and until it is have a certain time for combustion. We measure the time, the temperature T2 for the water, and apply this equation. The first part MC delta T will be the energy evolved, and then the lower part here M2, which is the mass of glucose divided by molar mass of glucose. We find out how many moles of glucose you burnt for the temperature rise of the water, and then you can have the calculation. 1 mark for effective communication because it has an asterisk besides the question. Now for part C, suggest two reasons. I don't know why I still write down one. Two reasons may be one, incomplete combustion of glucose, or heat loss to surrounding, or not perform under standard condition. This part quite well, you still remember. Okay. And for part D, why we cannot directly measure, okay, as used for enthalpy change calculation, because there will be formation of carbon monoxide. Okay, when you burn carbon, it may form carbon dioxide. You cannot neglect it. You cannot control. Okay, so that's why we cannot have a calorimetry for all reactions. Now this is question number 3. Now we move on to question number 4. Now why? It's about the chemical cell, okay, using a different metal couple. Okay, and the first one, part A1, why we need to clean the metal strip with sandpaper, because many of you write down removing impurities, but I want you to specific answer this word, metal oxide. In fact, for all impurities on the metal surface, suppose metal oxide only. Okay. So why we place a plastic board underneath for the setup? Because avoid electric charges falling to the floor. Okay. Otherwise, your measurement in voltage will have some problem. If you study physics, you should know this is earth. Okay, you earth the charges. So we need to place a plastic board, not current, not related to current. Current is physics term. For chemistry, we mentioned charges. Now the arrangement, okay, suggests an assumption for this experiment. The assumption is the further apart for metal couples in ECS, the greater the voltage. Sorry, I can't have the letter parts. Okay, the greater the voltage generated by the cell. 頭同尾嗰個 metal， 如果佢相距得越遠喺 ECS， 佢產生嘅 voltage 越大啦。個實驗個 assumption 係咁樣㗎。So for part C, arrange the 5 metal. Remember, from top to the bottom. From top to the bottom, that means decreasing order. I find some of you write down S, R, P, T, Q. Not this from top to the bottom, okay? It's an arrangement like this one. Okay? And which pair highest voltage? Of course, the first one and the last one, Q and S. So the voltage, you simply check it out from the table. Okay? How to arrive this answer? Because P is the reference electrode. And you'll find that if P and Q and P and S, okay, with 1.06 and 2.03, and you need to have these two, okay, adding together 3.09, okay, and then we have what we have in the experiment. Write half equation and explain the answer. Hydrogen first react to form hydrogen gas. Why? Because hydrogen has a lower position than Na plus. Okay, preferentially discharged. Remember this word. And lastly, we have the measurement of this ECS, similar to chemical reactivity series, is due to the tendency of losing electron. That means it can be easier to release electron or not. And this is question number 4. Now, question number 5. Another topic, reactivity of metal. So we have two experiments. One, addition of hydroxide to the iron, the metal iron. and the other acting aqueous solution of ammonia to metal ion. In fact, we related to precipitation, alkaline reaction. Now, let me know metal X and Y is simply zinc and copper. Okay. So part B, write another equation where acting hydroxide to X. The first one is a little hydroxide will form precipitate, white precipitate. But if we add further, there will be complex ion will dissolve. Many of you neglect the charge here, of course wrong. So part C the same, but asking you about copper. So copper will form copper hydroxide solid, blue precipitate. But if we addition of ammonia, it will display form complex and will dissolve for the blue precipitate. So what is Z? Z is aluminium or lead. How to prove? Chemical test. Okay, that means a new compound form. We add sulfates. Okay, white precipitate will be a lead because lead 2 sulfate is insoluble. You may add addition of sulfuric acid, addition of sodium sulfate, etc. But if not, it is aluminium, or you can show it is aluminium. Okay, but it's difficult because if you add hydroxide or addition hydroxide to aluminium, okay, again it will dissolve. So a Bechtle is using sulfate is Bechtle. Okay. So this is question number 5 and number 6 related to organic chem part 1. Okay. Now I use the lower parts then. Hazard warning label for methane flammable. Okay, flammable. But someone wrong spelling, not good of course. Please have correct spelling. For part B, the above reaction carry out under diffuse sunlight. Why? Because energy need to break chlorine. In fact, the first step is what you know. Chain initiation is to break the chlorine molecule into what we have chlorine free radical. Remember. So the energy is for breaking the bond. And for part C, let me know the observation. Okay, the observation will be white films or yellowish green color of chlorine phase out, or you mentioned decolorize is okay. And red dots or not? Yes, because chlorine decreases from 0 to -1. Your answer 1 is okay. Because I find that some of you write down carbon. But for carbon in organic chemistry, we seldom talk about oxidation number change. Okay, usually halogen. Okay, because chlorine is oxidizing agent. And part E is write down the electron diagrams to illustrate how ethane form. In fact, the first one, okay, because chlorine free radical will combine with the hydrogen here to form hydrogen chloride, which form methyl free radical. Okay, we have this before. And 2 kind of methyl free radical will combine to form ethane. Okay, which is the chain termination. Okay, so even you still you forgot. Okay, you the first one. I think the second one you can write it down. This is question 6. So we go to 7. Now, please read the question carefully. Name reagent G. It's about organic chem part 2. Okay, organic synthesis. You need to write down concentrated hydrochloric acid or phosphorus trichloride. Someone write down PCl5. It's correct, but it's wrong for this question because name. You may write down phosphorus pentachloride. Okay, but not PCl5 or PCl3 or HCl. Okay, because as name. Okay, name. For part B, suggest one advantage of using separating funnel. I find that many of you can answer separate two layers. But in fact, why it can be separated easily, I show you better. In fact, I expect you answer the latter part. They can be shaken thoughtfully. If you use simply picker, okay, or conical flask, of course you can mix them well by using glass rod, but you can't separate to two layers. But for separating funnel, you can mix them well and then stay for a while, and it can be separated into two layers again. So that's why we use a separating funnel. And part C, so strange. I find that most of you, I don't know whether you know 星矢 or not. 同一招對付星矢冇用。Many of you write down safety measure is wear safety goggles, wear safety gloves, using lab coats, etc. But please read the question carefully. Yes, using a separating funnel to carry out the above reaction, the safety measure. That means 針對你用 separating funnel 嘅 safety measure. Wearing safety goggles or lab coat or plastic gloves is referred to what you have in performing lab. But for measuring, using separating funnel is to open the stopcock several times to release the pressure. Okay, and again for part D, please go home and remember. And this question frequently found in public exam is how can you to have the pure product from the reaction mixture. I find that most of you just mentioned shaken the separating funnel and then separate two layers and connect. Sorry, not yet finished. Now you need to discuss the lower aqueous layer by addition of sodium hydrogen carbonate, or I show you the full answer here. Discard the lower layer. Okay, aqueous layer, we don't use it. And then we add sodium carbonate. Shake well, because to remove any acid remains in the product. After that, we remove aqueous layer again, because there will be sodium hydrogen carbonate. We are with acid to form sodium salts. Later on, we need to add this one. This one very, very important. We need to add drying agent like anhydrous calcium chloride. Okay, to dry the product. And then lastly, you need to have distillation to get the product, because even you perform this experiment, the product may not be pure. And then you want to get back pure product, you need to have distillation, because 2-chloro-2-methylpropane with a lower boiling point than alcohol. Because alcohol with hydrogen bonding, but chloropropane will have only dipole-dipole forces. Okay, and then of course effective communication mark. And many of you already forgot how to calculate percentage yield. Percentage yield is you find out the expected number of mole of the product, okay, here, and the product form is this one, theoretical yield and actual yield. And then you use the actual yield, okay, divided the theoretical yield times 100%. So this is the correct value for percentage yield here. Please have this idea. Very common, no matter paper 1 or paper 2, find a percentage yield. Okay? And question number 8. In fact, it's I modified one past paper. Okay, not exactly the same, but I make it from A level. A bit difficult, but I find that many of you already forget the content about equilibrium. Now, given the information from the question, and you try to calculate the molar concentration in equilibrium mixture, how to do it? Many of you take account in carbon. Remember, for equilibrium, we only count gas or aqueous. But for solid, it's not related to chemical equilibrium, right? Because solid without any molarity. So if you count this one, 1 and 1 minus x, of course you will get wrong answer. So what that means, the equilibrium constant will simply x square divided by 1 minus x only. And you solve the quadratic equation, you will get only x equals 0.32x, and then you count the equilibrium molarity for the steam. Okay? Maybe you find that this question is a bit tricky, but you need to know, remember, for equilibrium, only gaseous state or aqueous solution can be taken account because they have a molar concentration. For water, usually we don't take account, but for steam we did. But for esterification, remember, I show you water is a kind of quantity we need to calculate in equilibrium, exceptional case. So, for part B, again, a bit difficult for you maybe. Usually, the public exam will ask you, will there be any chemical position, equilibrium position change? And then you explain why. But this time, I show you the change and ask you why there is a change by means of physical action. What that means? Now, from the question, you find that for part A, both steam and carbon monoxide changes. And some of you write down, because I removed the reactants. I'm sorry, it's not the correct answer. Okay? Because the question is asking you, for time A, B, and C, deduce what changes you have taken. Maybe you think that I can remove the steam and carbon monoxide, right? However, please have a look for the equilibrium here. How can you only remove CO and hydrogen, but without removing the steam? Can you? Because in this mixture, it's a gaseous mixture, just like air. Can you simply take out carbon dioxide from air, but not others? Under, of course, in the equilibrium, no. So what that means? That means for this part, you can only increase the volume, but some of you write down decrease the pressure. Yes, you can. You can use decrease in pressure because decrease in pressure means a volume increase. Okay, and also decrease the pressure. Here, 1 mole of gas, here, 2 mole of gas. Of course, there will be, want to have a change. Decrease in pressure, decrease in pressure, that means you want to make the pressure increase again. That's why there will be a sudden change for A. But usually we use volume increases. Because volume increases will dilute the molar concentration. For B, you'll find that there will be a sharp increase in steam, only one straight line. That means the steam is added to the equilibrium. It's a sharp straight line, but not for CO. And lastly, the easiest one. The steam decrease but carbon monoxide increase is due to the temperature of the system increase. Okay? So that's why we have this change for equilibrium. As the question related is exothermic reaction, okay? Now, next page, which is question number 9. Now here we have inorganic chem, and talk about, again, electrical conductivity for group period 3 elements. Now the graph show the first part, which is related to metal, increasing trend. The second part, decreasing for silicon, and no conductivity for these 4 elements. And then explain the trend. Easy. You simply remember the stuff from the textbook and explain the first part why increasing, because giant magnetic structure with more delocalized electron. Okay, but the last part, why? Because simple molecular structure, no mobile ions or delocalized electrons for conduction of electricity. And that's why we can explain the trend like this one. and then related to weight of reaction. Now, given that the temperature of and concentration of A remains unchanged, so B double, what happens for reaction rate? Many of you write that increases. Of course, it will be increases, but that means what extent it increases? 4 times. Okay, here we have 4 times. How about A and B double together? So it will be 8 times, because for the order of A is 1, the order of B will be second. Okay, that means square. So if you both double, we'll 8 times the rate. For part C, most difficult question in this revision test. If acid is the catalyst, the acid will be present in weight equation explained. It cannot be determined. Why? I find that some of you write down the acid should be contained in the weight equation because it related to reaction. Because it's catalyst catalyzed the reaction weight. However, please bear in mind, no matter it is a reactant or a catalyst, how it affects the weight depends on order. If the order is 0, that means no matter how many catalysts you added, it still cannot catalyze the reaction. Shows no effect in the weight. It can, because the only thing you can find out catalysts can change the weight or not is to perform experiments. Okay, here, in order to find out the order of reaction, if we don't have the order, we don't know whether the catalyst can increase or even decrease the weight of reaction. So bear in mind for this. Of course, in elective part, usually we mention if we add catalyst, the reaction rate will be increased, but not all the time. Okay? Now, for part D, addition of water, many of you write down fair test. In fact, it's not related to fair test. In an elective part, I mentioned. Why we need to keep the total volume? Because it equals proportional to volume of A, proportional to concentration of A. If the volume are the same, what that means? If the total volume is 100 cm cube, you addition of different volumes of water in order to make different concentration of A, different molarity of A, but not because of fair test. Okay, fair test is what we learned in IS. But for chem, we use, because we want to show variation of concentration of A. So it shows it have different concentration if we have different volumes of water. Now, why we need to have a much higher concentration of molarity of B, I mentioned in the lesson many times, and please remember this answer. Large excess in B, because we don't want B to show any effect in the reaction rate. Ensures the weight of reaction depends on the change in A only. This is the main reason why we need to have high and large volume of B, high concentration of B, in order to let only A affect the reaction rates. So lastly, find out the calculate the value of X and calculate the value of Y. Many of you with missing unit. Okay, but this time just a revision test. Bear in mind it is per minute, not per second. Check it in the table, in the question. Okay, it's per minute. So the last question is related to elective again, about green chemistry. In fact, not well. For method, with reference for material which is least sustainable, least, I use the term least, but not most. Least, of course, is method 1 because ethene cannot be renewable from cracking of oil. And then for part B, calculate atom economy, just write down 100%. I know, because no side product. But you need to show the calculation, how you calculate the atom economy. Okay? Don't just write down the answer I mentioned in the lesson already. How about part C1? Again, calculate the atom economy because there is side product, so the atom economy will not be 100%, 51.1. And explain why the reaction has a relative low yield. Many of you related to atom economy. Actually, the yield is referred to how much product form actually divided by theoretical yield. Why? Because when you perform fermentation, the higher concentration of ethanol or alcohol will kill the yeast and stop the fermentation. That's why you cannot make so many ethanol, because at a certain percentage, the yeast will stop the reaction. Otherwise, more ethanol produced will make the yeast die. I think you study biology, you should know something like osmosis. Okay? So that's why the yield of this reaction will be lowered. And the last question is open-end. And you may answer green one, method 1 is greener because high atom economy. Okay? Or method 2 is greener because sweet corn use is renewable. Okay? Or any other reasonable answer, but no contradiction. Okay, and that's all for the solution of structural question.